Let's read this example. In clinical trials of the anti-inflammatory drug Inflamanex, adult and adolescent allergy patients were randomly divided into two groups. Some patients received 500 micrograms of Inflamanex, while some patients received a placebo. Of the 2,103 patients who received Inflamanex, 520 reported bloody noses as a side effect. Of the 1,671 patients who received the placebo, 368 reported bloody noses as a side effect. Is there a significant difference between them, or is there significant evidence to conclude that the proportion of Inflamanex users who experienced the bloody noses as a side effect is greater than the proportion of the placebo group, in this case at a significance level of 0.01. So like before, we'll try and split our two groups into separate populations. So let's identify what we're going to call P1 and what we're going to call P2. In this case, we're looking at one group that received the drug and one group that received a placebo. And so, while P1 represents, in this case, remember what we're trying to look at is the proportion that received bloody noses. So, P1 will be the proportion of the participants that received the drug that also got bloody noses. So, okay, well that's a lot to write, but here let me squeeze that in there. So it's the proportion of the drug recipients and got a bloody nose. Okay, so remember that's what we're really looking at with these proportions, is the proportion that got a bloody nose, and we want to see, is there a difference between the group that got the drug and the group that got a placebo? And so in P2 is the proportion of those that got the placebo and got a bloody nose. Right? So again, the idea is that when you give one group a placebo, you don't expect the drug to affect the group that had a placebo. Instead, we would expect the group that took the drug maybe got the side effects. But if the drug really wasn't causing any side effects, we would expect there to be no difference between the two groups. And so our null hypothesis will be that these proportions are the same. In other words, the proportion of the people that took the drug that got a bloody nose is the same as the proportion of people that took a placebo and got a bloody nose. Now, in the case when we have that the Inflamanex users were more likely to get a bloody nose, then we would expect P1 to be greater than P2. In other words, we would expect the proportion of those that actually got the drug to have a higher percentage of bloody noses than the group that took a placebo. Okay, so before we go, let's collect our sample data. So between our two populations, P1 and P2, P1 will be those that received the drug. And let's see, so we had 2,103 patients that received the drug. 520 of them reported bloody noses. So that means we have a sample size of 2,103 for that population, where 520 received bloody noses, so we'll use N1 is 2,103. It's N1. And then 520 received bloody noses, so we'll call that X1. And then the group that received the placebo, we've got 1,671 that were sampled here, so we'll call that our N2, the sample size for the second group, where 368 reported bloody noses, so that'll be X2, this successes in our second group. So we'll use N2 is 1,671 and X2 is 368. And right there we have all the information that we would need to plug into our calculator. So let's go ahead and plug it in. So we need these two values here. We need these two values here. And we need the form of our alternative hypothesis. So I'm going to punch all this. So rather than doing that long formula to get the test statistic, we saw how we could do that in the previous slide, so I won't spend the time writing that out this time. Instead, I'm going to do it the way that I would prefer to do it in general, which is to use the calculator formula that we're always going to have available to us. And it'll spit out the test statistic for us very, very easily. Okay, so we're going to go to 2prop z-test. All right, so let's pull that up. 2prop z-test with X1 is 520, N1 is 2,103, X2 is 368, and N2 is 1,671. And then the form of our alternative hypothesis, we want to make sure we use the one that says greater than P2. Okay, so it matches our alternative hypothesis here. Okay, and after doing that, I get the test statistic 1.945. Okay, in the next slide, we'll look at the graph and write out the p-value that we would get. So in this case, we were looking at a right tail graph because here it was using the greater than symbol, and the p-value that we got was around 1.94. So the p-value would be the area to the right of that, and in this case the p-value that we would get was 0.025. 0.258. And so let's see what kind of decision we can make now. We've computed the p-value, 0.02588, and comparing that with the significance level alpha equals 0.01, and that was the given alpha that we're going to use. We actually see that the p-value was a little bigger than that significance level. So it didn't quite give us a small enough p-value to warrant any rejection of the null hypothesis. So in this case, we're going to fail to reject. So what kind of conclusion can we draw from that? Well, in this case, the conclusion is that since we failed to reject the null hypothesis, there is not enough evidence to support the claim that P1 is greater than P2. Okay, essentially there wasn't enough difference between the two different samples to warrant us to have enough evidence to support this claim here. Okay, so the conclusion is that essentially this is an inconclusive result, so there's no conclusion. that can be drawn from this data about whether or not Inflamenx causes nosebleeds. Okay, so maybe if we were to perform a different experiment, we might have more conclusive evidence. But in this case, because the sample between the two groups were not different enough, we weren't able to make any conclusive decision. Here we have the calculator formula that we just used, entering each of the sample data between our two samples and the form of our alternative hypothesis. Right, so either P1 is less than P2, P1 is greater than P2, or P1 is not equal to P2. So one of those forms.